Today's session, we are going to cover two topics. The first one is point-to-point protocol. We also call it as a PPP. Probably this you would have covered in your data communications subject course in the last semester. To just remind what you have covered in the last semester, probably you would have understood the concept of point-to-point, and you would have heard something called there is a PAP and CHOP protocol, PAP and CHAP CHOP protocols. This you would have covered in the last semester. Probably we'll also see now in our tour. And the other topic which we are going to cover is frame relay. Our major focus is going to be on configuration of frame relay for today. Though we cover point-to-point protocol, the basics, but our major focus is going to be on frame relay configuration today. All right, because this frame relay is part of your laboratory experiment also. So going further, let's say point-to-point protocol. What is point-to-point protocol? So this point-to-point protocol provides a standard, or let's say a transporting mechanism for multi-protocol datagrams over point-to-point. To make it easy for understanding, the point-to-point protocol, all right, where I am going to apply is in a topology. Let's say you have got a topology here. So in a diagram, if you say if your user wanted to connect to a particular server, right? And in the middle, it might be a direct connection, or it might be a, let's say, a group of routers, or let's say a network edges coming into the play. I repeat. So now let's take this environment. If a user wanted to connect to a particular server, the connection might be a direct connection, or the connection might be a combination of a group of network edges, where you have a routers in between, n number of routers, where you have n number of switches also might come in between. So it might be in this situation. Now, when the user wanted to connect to this server, we need to establish a direct contact or a direct channel between these two people. The packets cannot go in a multi-directions, right? Now, I need to establish a link between these two end devices, point number one. Point number two, when I'm establishing this link between these two end devices, as I said, when there are n number of routers coming into the play, they may use a different routing protocols. That's what we are trying to understand, a multi-protocol datagrams. All right, they may use a different routing protocols, but however, our packets has to cross those routing protocols and reach the server. All right, so I repeat the concept. I repeat the scenario. Now take this topology as an example. We have an end user who need to contact, let's say, a particular server. Now there might encounter, or we might encounter two scenarios here. The first scenario, what is first scenario? It might be directly connected using a single channel directly connected. That is the first scenario. Second scenario might be this path might be a combination of, or a group of n number of routers. We usually call it as a network edge. We do not know how many routers in between. We do not know how many routing protocols have been used, or how many other transport protocols have been used in this. All right, we are not aware, completely unaware. But however, our communication has to reach across this multi protocols what it has been configured and to the server. In that case, I need to make sure my data is secure because it is crossing multiple protocols and other things. So we may use some PAP or CHOP protocol to secure other things. But point-to-point refers to where a standard method we're going to provide for transporting multi-protocol datagrams or point-to-point links. So that is a major purpose of our point-to-point protocol. Now, coming back, the point-to-point protocol is comprised of, let's say, three components. Whenever I wanted to establish a point-to-point protocol, I need to take care of three situations or three components. What is that is? The first one is a method for encapsulating a multi-protocol datagrams. Now, I should have a method where my packet is encapsulated, uh, uh, which can face or which can pass through a multiple datagrams. That is the first component. The second major component is we are going to have something called LCP and NCP. All right, we call it as a link control protocol and network control protocol. So that is also, or these two protocols are point of your, let's say, part of your point to point. Now, what is the purpose of link control protocol? Is It majorly focuses on establishing and configuring or testing your channel or testing the channel. All right. What is the major focus of network protocol is? It is trying to establish a connection between layer 3 devices. Right? That is going to be your major focus. That's what we're going to understand here. So to revise, what is point-to-point protocol? It gives us an environment where we can connect to a remote server or remote device using you can even say it as a dedicated channel, or you can say it as a secured channel. All right. So now, when it is establishing the secured channel, we may encounter multiple protocols in between. So our packet has to pass through those protocols or whatever you call it. Now, going for the next step, the point-to-point protocol is comprised of three components. One, we say it as the first component encapsulating your datagram, because we also say the point-to-point protocol is part of your data link layer. It is a layer 3 protocol, or let's say layer 3 concept. Sorry, layer 2 concept. It is a part of your data link layer. All right. So that's the reason we call it as a frame or whatever it is. Or frames are going to come into the play. So the first component is it is a method for encapsulating the multiple datagrams. The second component, we have something called LCP, we have something called NCP. Now, what is the purpose of LCP? It is it will help us to establish or configure or test the data link channel, right, between the two end devices. And NCP, it will establish and configure a network, or let's say layer 3 protocols. So that's a major focus of your point-to-point protocol. To understand more clearly about this point-to-point protocol, let's see. Now this when you say it as a serial communication, so we have bytes which has to be sent. We have a channel. We may use a time division or frequency division, whatever it is. So we call it as a serial communication. Every data will pass through the same channel and go through it. When parallel communication, we have the bytes which can go across multiple links and reach the destination. Right? So why we are doing this? Because we may link a point-to-point protocol in one-to-one group, and let's say there's a frame relay into other group. We'll see that also. Let's not worry. So we are just trying to understand before going more clear explanation of point-to-point protocol. We are trying to understand what is serial and parallel communication. When I say serial communication, we have a channel where all the bytes or data will go through that channel. Parallel, we have a multiple channels which will go through that. Let's say it as a channel. Fine. So that's what. Just to give an example, we may, if it is a let's say serial, we may use a time division, or let's say we may use a frequency division. We have multiple parameters or multiple ways to partition a channel. We have a channel partition methods. That's what we use: a frequency division, time division, or whole division multiplexing. Right? We use a concept called multiplexing, and from where the packets will be traveled. Right? Then you also know there is something called Dte and Dce. All right. So now, just revise the Dte and Dce. Let's take the first topology here, an example. We have a router here, and then we have a router other end. And the first router is connected to let's say a switch, and the other router is also connected to a switch, and then thereby we have some let's say a network edge here. Right? Now look at this carefully. When I connect from a router to a switch, whenever I take an interface, I call the other end as a Dte, the other end as a Dce. Right? Kindly note it. Then when it comes to a switch to switch connection, I will call both ends, or I'm gonna call it as a DCE only. The switch will hold a DCE, and the switch also will hold a DCE. All right. When we say again switch to a router, we are gonna give it as a DTE here. The other side is DTE. All right. Now, what is DTE and DCE? DTE is called it as a data terminal equipment. What is the purpose of that? End of the users or devices in the WAN link. All right. When we say DCE, what is that? End of the WAN provider's side of the communication facility, responsible for providing a clocking signal. All right. Now, the point you need to understand from the first topology is we have something called DTE and DCE. DTE represents to a data terminal equipment. DCE represents to a data connection or let's say communication equipment. All right. Now, when I use a DTE or when I use a DCE. Now, router to router, I'll come back. We have the second topology here. We'll come back router to router. Now, we are trying to understand when it is a router to switch, the one end, we're going to call it as a DTE. The other end, we're going to call it as a DCE. When switch to switch, or let's say in between, we are not sure how many devices coming into the play. It might be n number of devices, or it might be a direct link also. All right. Then I call it as a DCE and DCE. Again, from switch to the router, we call it as a DCE and DTE. That is the first point. The second point is we have something called clock signal or clock rate. We used to set a clock rate. If you observe in our previous topologies, whenever we are trying to configure a serial communication, we used to set a clock rate. Always keep it in mind, the clock rate will be set at only the DCE side. Right? I repeat, clock rate will be set only at the DCE side. The other DTE will sync with the DCE. All right. If the DCE says I need a clock rate of 1200, the other router or other device, other end has to sync with the 1200. Right? Fine. That is the second point. Now, coming to the next point here. What happens if it is a router to router? When the connection happens between router to router, now it is optional, or it is one end it can be a DCE, one end it can be a DTE. It can be a vice versa also, right? It's not always fixed saying that you have to fix DCE here only, you have to fix DTE here only. It might be vice versa also. All right. So router to router, we have both existing DTE and DCE. Again, when it is DCE, we'll set the clock rate. One end we're going to set the clock rate. All right. So that is the 3 points which we wanted to understand from this slide. So just to revise the 3 slides, all right. First slide, we are trying to understand what is point-to-point protocol, right? Point-to-point protocol, which will help us to send. It's a standard method for transporting our data, let's say, through multi-protocol data graphs over a point-to-point network. It has got 3 components. One is first component, we say it as an encapsulating of your datagrams. Second component is LCP. Third component is NCP. Right. What is the first component it is going to do? It is going to encapsulate your datagrams. And it is going to give it to the next layer, that is third layer, the link layer, or let's say it is at the receiver side, it may give it to the layer 3, or at the source side, it will give it to the layer 1 or whatever. And LCP, it will make sure there is a connection established or configuration, or it is going to test the link also, whether it is fine or anything issues with the link is going to test. And NCP, it is, as I said, it is going to establish and configure the network layer protocols, that is layer 3 protocols. It is going to take care of layer 3 protocols. Now, to roughly understand NCP, how it is going to take care of layer 3 protocols, see, as we have seen in the network edge, there might be n number of protocols coming into the play. We cannot expect everybody to use the same type of protocol what we have used. So when there are n number of protocols coming into the play, when our packet is traveling, now NCP takes care of this uniformity, so that our packet will go through all those protocols. We'll see more in clear also. All right. So the second concept we are trying to understand is there is something called serial and parallel communication. When we say serial communication, the bytes, whatever it is, we are trying to send it to a serial channel and to the receiver. When we say parallel communication, the bytes or data might go in a number of portions. And again, when it is serial communication, we have an options also called, let's say, time division or frequency division, other time channel partitioning techniques. All right, we are not going to focus more on partitioning. What is time division or frequency division? This you would have covered in the last semester already. Right? We have a number of channel partitioning techniques. All right. The next point we try to understand is there is something called DTE and there is something called DCE. Now, what is DTE is basically we call it as a data terminal equipment, and DCE is data communication equipment, and DCE will initiate always the clock rate. DCE will initiate always the clock rate. Now, we may encounter 3 different scenarios when you are configuring or when you are assigning DTE and DCE. The first example or first scenario is between to the router to the switch. Then I call it the router as a DTE and switch as a DCE. If it is switch to switch, I call both as a DCEs. Right? When it is router to router, it can be one side DTE and one side it can be a DCE or whatever it is. It can be a vice versa. So that is the next point we try to understand. Going more closer, let's see. Now there are three environments here. The first environment, it might be a scenario, a router to router. It might be a leased line. It might be a leased line, or you can say it is a dedicated or whatever you call it. It might be a leased line. So in that case, I may use in between the protocols, which we call it as a HDLC or point to point, or there is something called SLP protocol. Right? The first scenario, if it is a router to router, all three scenarios are router to router only. The first concept is if it is a leased line, these are the protocols which we are gonna use. All right. Now HDLC, point to point, and SLI. Right. Now, the other way to understand, now you can even say point to point is an extension of HDLC actually. The initial stage, the HDLC has been proposed, then it has been modified version as point to point protocol. You can even take it in that one. The second scenario is we have something called circuit switch networks. This also the concept of circuit switch or packet switch networks we would have studied in data communications. All right. The second scenario, we have a circuit switch network. Now, if you see an example here, this kind of topology, there are, let's say, n number of routers coming into the play in between. Then, if it is a circuit switch network, I go with the HDLC or point-to-point protocols or SLI. All right. The third scenario, if it is a packet switch networks, and we have, let's say, it is a telephony company or it's a service provider or whoever it is, n number of routers in between, then I may use the protocols called X.25 or frame relay and ATM. Right? These protocols. We have to use these protocols. So you need to understand we are going to cover where the point-to-point protocol comes, right? At what scenarios and where the frame relay and ATM comes. All right? Because these are your part of your syllabus. And this you would have covered in the data communication. All right. So to make it clear, in the leased lines, we use a point-to-point protocol. In a circuit switch network, also we use a point-to-point protocol. How we use that we'll see. All right. We are just trying to understand the preamble. And if it is a packet switch network, we use a X.25 protocol or frame relay or ATM. Right. These we are going to use. So it might be that's what we're gonna call it as a WAN level or WAN encapsulation protocol, and it is a wide area network. All right. Now, as I said, again, initially, before the point-to-point protocol has come into the existence, Cisco has designed its own proprietary protocol called HDLC. Now, after some modification in HDLC story, what happened? It has come to it has designed a protocol called point-to-point protocol. Right? Probably you can say the next versions of HDLC is a point-to-point protocol. What was a major change brought in when the point-to-point protocol introduced is one of the major change. Initially, when the system, since it was proprietary, it works only between the Cisco routers, a Cisco router to a Cisco router. Probably, if we encounter, let's say, another Juniper router or let's say another XYZ company's router, the HDLC was not supporting uh, between multiple products or multiple routers. Right? So HDLC was successfully implemented when the both ends are the same, let's say Cisco router, because it is a Cisco proprietary protocol. Later, to make it public, it has been modified as a point-to-point protocol so that the communication can happen even from Cisco router to a Juniper router or to a other XYZ router also. All right. So manufacturing or whatever you call it, inter-domain or whatever you call it, the routing can happen. So that's what. See, if you see HDLC is a default encapsulation method between Cisco routers. All right. Use a point-to-point protocol to connect a non-Cisco router. Right. So one end it might be a Cisco router, one end it might be a other product, other company router. then I go with the point-to-point protocol. So that's why we say initially it was HDLC. Then to make it public, it has been modified, or let's say the next version has come into existence, that is point-to-point protocol. It will help us to encapsulate or communicate between non-Cisco routers also. Now, when we say point-to-point protocol, as I said again, it is a combination of, or it is a first HDLC. All right, then it has been modified to point-to-point protocol, and let's say it has got LCP and NCPs, link control protocols or network control protocols. What is link control protocol is going to do? It is going to make sure that there is a channel or communication established, secured communication established. What NCP is going to do? It is going to take care of the routing of your packets, network level or layer 3 level packets routing between multi-protocol environment. It will help us. So now, what is there are some stages part of your point-to-point protocol. The first, we say it as a link establishment. When two routers are trying to communicate, they are going to participate in a negotiation, and they're going to establish a link. Right? That's what the first phase in a point-to-point protocol, link establishment. Then the second phase is going to be determine the quality of the link or link quality. Maybe we should discuss on some details about quality or may not. So they come on the quality, the second negotiation happens. The third is, that's what we say it as a network protocol negotiation. Okay, it's like, okay, I will leave it to your NCP to discuss about the. So what protocol we're going to use to communicate, right? Whether we have something called internet or let's say not internet protocol, IAIP, that is Internet Addressing Protocol. There are some of the different protocols coming to the play here. So it is a three-stage negotiation. First stage, it will negotiate for the connection. Next stage, it will negotiate for the quality. And then the third stage is it will negotiate for the what protocol we are going to use it. So this is a kind of a flowchart, what LCP does. All right, if you look at carefully, so the first level, interior senders or configures request message. The sender is going to send a request message as a first level. Let me give you here. So this is the first level. He is going to initiate a request connection. Now, the responder process, the next level is the responder process the configuration request. After processing, options is it can be accepted or it can be rejected. You can see, yes, it can be the connection is established, or no, the connection is not established. It can be rejected. Suppose if it is rejected, let's say example, if says the connection is not established. So why, or let's say all the options are recognized, or let's say it as a, we are going to say it as a, yes, we'll send a negative acknowledgement saying that your connection is rejected. Or let's say, or responder sends a configuration reject message. Now, the reject also can be let's say in two ways. It directly says, no, I'm not accepting a negative acknowledgement, or it is going to reject saying that for that particular reason, it is a rejected. So when it is rejected, what has to be happen? The interior process response determines new negotiation. So it may send a new negotiation. We have to, the responder or whoever it is, the request has to go as a new. Again, it has to go to the first stage. Right? So to understand again the process of link establishment in a point-to-point protocol, at a first level, you say interior, or you can say it as a sender initiates a connection request. Now, once the connection request is done, it might be rejected or it might be accepted. If it is rejected, it might be sent as a negative acknowledgement. If it is rejected only for a certain communications, it may give that reject message and send a reply. So when the responder responds in this way, the sender has to analyze it, and if he has to initiate a new connection request. So this is a stage when it goes on a rejection process. Suppose if the connection is established, he's going to send an acknowledgement, and then the configuration is accepted. Then we are going to use something authentication, authorization. If the authentication is failed, or let's say whatever it is, if authentication is used, we'll go through that process. If authentication is not used, we'll go directly the communication to the next level, right? So this is the flow of your LCP, link control protocol, how LCP acts in a point-to-point protocol. All right. Sorry. So now, so these are the few components again we're going to use. Probably we'll see this in a topology. We have a packet or negotiation, error, authentication, and compression or CDCP. We'll see in that. This points we'll see in the topology. Now look at this. Point-to-point protocol, when the negotiation happens, or let's say when the connection request is accepted by the responder, or let's say the receiver, as I said, there is an authorization process. That is the next level. If you see in this topology, once the connection is accepted, there is an authorization process. So it might use authorization, it might not use the authorization. If the authorization is used, we have a two types of authorizations. That's what those we call it as a PAP and CHOP protocol. All right, we call it as a PAP and CHOP protocol. Now, what is PAP? We usually say it as a two-way handshake. The authorization will happen in two-way handshake mechanism. What is CHOP? The authorization will happen in a three-way handshake mechanism. Now, what is difference between two-way and three-way handshake mechanism? If you see in two-way handshake, the initial router will send the username and password for a connection establishment. And then you get a reply saying that accept or reject. This is a two-way handshake PAP protocol. When we say it as a CHOP protocol, when you send or initial, let's say it as a, when you send something like username or password, whatever it is, then there is a something like challenge is given to you, like something like OTP or something, which you need to authorize in the second level. Then the connection might be accepted or rejected. Right? It's not only the username or password which comes into the play. It might be a challenge. There is a challenge given by the designated router or designated router also. You authorize. I'm okay. You gave your credentials. Now I'm sending you OTP. You let me know. Still, that's the next level of authorization. So that is a CHOP protocol. Right? We usually call it as a two-way handshake and three-way handshake. Now, PAP and CHOP protocols are part of authorization in a point-to-point protocol. So that's what PAP is. It is going to send a username and password, initiate, and get it. CHOP is a three-way handshake. The designated router will give you a challenge so that you have to crack it, and then it will accept the authorization. Okay. So this is all about your point-to-point protocol. This is all about your point-to-point protocol. Now, for frame relay, I'm not using any slides except the first slide. We will directly go to the topology. Now, before I go to the frame relay configuration or to the topology, all right, any doubts as of now? Doubts as of now? Before I go to the configuration of frame relay or let's say point-to-point, let's say simulation, any doubts as of now? If there is any doubts, I'll be happy to answer. If not, we'll go to the configuration. So to summarize or to revise the complete point-to-point protocol, so what is point-to-point protocol? It will help us to transfer or transport or let's say send our data between multi-protocols when there are multi-protocols from one end to the another end. There are three components of point-to-point protocol. One, we say it as a first level, we call it as a data encapsulation or encapsulating our datagrams. The second component is LCP. The third component is NCP. So what is an LCP is gonna negotiate with the connection. It is gonna establish the connection or it is gonna configure the connection. What is NCP is gonna do? It is gonna help the layer three. Layer three when the packets has to be traveled in or with the multi protocols. Now, part of LCP connection establishment, we have also seen how the LCP works. There is something called PAP and CHOP protocols coming into the play, part of LCP. So, what is PAP? That is a two-way handshake, and what is CHOP? It is a three-way handshake. So, to make it more clear, PAP, when you want to communicate with the designated router, it will ask you to authorize yourself. You may send your username and password that will be validated and the connection is established. Right? That is a PAP protocol. What is CHAP protocol? When you wanted to connect to a designated router, along with your authorization, or let's say username and password, once you submit the first level, the second level, it may send you something like OTP asking you to validate it again. So that is there is a second level of authorization also. Then, if the OTP or something like that is validated, then the connection is established. That is a CHAP protocol. So that's a summary of your point-to-point authentication, or let's say point-to-point protocols. Now, let's understand the frame relay. Now, this is one slide we'll use from this frame relay, then we'll go to the directly. Now, look at this topology clearly. We have a router here, right? We have a router here, and there is another router. Yeah, probably this is a sending router, and this is a receiving router. The packets are traveled across a network edge. The packets are traveled across a network edge. As I said initially, it might be a 5 devices coming into the play in between here, or it might be 10, or it might be 100. We don't know the number. Point number one. Point number two, we don't know the communication type. It might be X communication between this device to this device. It might be another type of communication channel between these two devices. That is point number two. So I repeat, point number one, we may have a network edge, the combination of n number of devices. All right, instead of 5, let me keep it as a n number of devices. Right, the combination might be n number of devices. Sorry. So when we take this, the combination might be n number of devices in between. That is the first point. Second point, these devices might be connected using a type 1 and type 2 channel. Let's not worry what is that type channel. These devices might be connected using a type 1 and type 2 channel. All right. The third point is these devices may run n number of protocols for the communication. One might be working on using a RIP, one might be working using a, let's say, BGP, one might be working using another type of routing protocol. Third point. Fourth point, they may have n number of network layer 3 protocols also for encapsulating or transporting your packet. Now, so these are the 3 points. Try to understand from this. Now, when it comes to the frame relay, the concept here is using a frame relay, we will try to push a packet to this network. Right? Up to reaching to this network, we may use a layer 3 addressing, that is IP, up to reach network. And then the packet may travel in n number of, let's say it as a paths, and reach the destination. Again, we use a layer 3 here. All right. And then we have something called DLCI, Data Communication Link Identifier, data channel or data communication link identifier. We use the DLCI numbers to identify the destination. All right. So how to identify? Through which interface it is connected. That means I need to identify, okay, this is the connecting point for this destination. This is the connecting point for this source. So I will identify these people as using a DLCI. All right. So let's not worry if you do not understand these points. We'll try to configure it. From the configuration, you will understand more. All right. So let's go to the configuration directly. All right. So hope you are able to see my screen. Can you see the screen? Anyone? Can you just drop me the text box? Can you see the start box?
Yes, sir.
Okay, thank you. Now, look at this. To configure a frame relay, what I'm going to do is the first step, I'm going to end network devices, and then I'm going to use something called WAN emulation, a cloud type environment. Right? So that's what we are trying to understand. We are not sure how many devices will be there in between in the network edge. We're not sure. It might be n number of devices. It might be uh, n type of devices also. Right? We are not sure how many devices are there in between. We are just trying to take it as an emulation. That's what I can select this using a, let's say, network devices. From there, you can go to the last option. There is something called WAN emulation. So once you click on WAN emulation, you have got an emulation type using a cloud, or let's say a cloud WAN emulation, which we have taken here. Now, point here is it might, as I said, from the it might, this is the kind of environment. You see the topology here. This cloud or whatever we are choosing here, that might have this kind of environment, right? For that reason, we are using this cloud environment. Right? Then, second step is I'm going to take some three routers which are connected to this cloud environment. I'm going to take some three routers which will be connected to the cloud environment. So for easy to remember, we're going to rename this as a router 1. We're going to rename this as a router 2. We're going to rename this as a router 3. So I'm going to take three routers to connect. Fine. So let me connect. So, but when you're connecting, look at this carefully. The clock rate DCE has to come to the cloud side. Now look at this image also. It is going from router. It might be a switch. It might be a router also. But we are going to assume in this cloud environment, switch or whatever, multi-layer devices, whatever. So what I'm going to do is I'm going to connect from here to here, and I'm going to make sure the clock rate turns to the cloud side or WAN emulation. The clock rate is towards the WAN emulation. I'm going to do the same here from here to the router, and the clock rate should be towards. It may have also happen when you're trying to configure the clock rate might be other side. So you need to just take care of that. All right. Then no, it should not be a serial. It should not be a this. We take a serial and we connect from here to serial. Right? So this is the first step. So we have taken a cloud environment or WAN emulation. You can call it as a cloud or WAN emulation. Then we have three routers, router 1, router 2, router 3. Fine. Now, what I'm going to do is, I'm going to take some end devices. Let's take some end devices. 1, 2, 3. Right? These end devices are, let's say, directly connected to the router. End devices are directly connected to the router. Fine. That is a step 3. Right? So, or let me write the steps here. Configuring a frame relay. Right? First step, what we are doing is we have taken the we have configured the physical devices. Let's say configure or connect the physical devices. That is the first step we have done. Now going further, second step is look at this carefully. I am gonna take 192.168.1.0 for this network. I'm gonna take, let's say this might be very good. This might be 192.168, let's say 2.0 network. This might be a different class also. You can say 172 or 168 because this might be a different class also. 0.0. So I'm going to take this. So And so for the end devices, or let's say network, so to understand, for this network, we have taken 1.0. For this network, we have taken 2.0. For this network, a different class, we have taken it as a probably 68.0.0. The important point you need to notice, when it is a WAN kind of emulation, look at this carefully. I'm going to treat this complete as a one network. I repeat, when it is a WAN kind of emulation, I'm going to treat this complete as a one network. Why I'm going to treat it as a one network? Because it might be a Airtel network edge. It might be a BSNL network edge. It might be a Geo network edge. Right? So I'm going to treat this complete network edge as a one network. So when I treat this complete network as a one edge or one network, look at this carefully. I'm going to use 192.168. Let's say 3.0. All right. I'm going to use 3.0 for this WAN emulation. So in that case, when I use 3.0, I'm going to use 3.1 here. I'm going to use 3.2 here. I'm going to use 3.3 here. And I'm not going to use anything here. Point to be noted, because that's where our DLCI come into the play. All right. We are not going to use anything here because we don't know to which router it has been connected. So we don't know to which interface this has been connected. We don't know which interface it has been connected. We don't know which, sorry, not interface, port it has been connected. Right? So we are not going to use any IP address here. Right? But to post or to help packets, NCP, that's what we are trying to understand. We use a DLCI numbers. Let's not worry. We'll see what is the DLCI numbers. Right? How do we configure it? So first point to be understand here is we have used 1.0 network up to here. We have used 2.0 network up to here. We have used 3.0 network, sorry, 168.0.0 network here. And then we have used 3.0 network completely in the intermediate, in between. All right. So let's configure that. The IP, let's assign the second step. What we are going to do is we're going to assign the IP addresses. Assign IP addresses. That is the second step we are going to do. Let's assign the IP addresses. So I'm going to take this laptop. And I'm going to say your IP address is going to be 192.168.1.1, and your gateway is going to be, let's say, 1.2. Right? Let me assign this interface also. I'm going to use 1.2. I want to say this. So we have assigned this end device and gateway. Let's assign this side also. We're going to take this as 2.1, and we're going to say gateway is going to be 2.2. Right? If we go to this interface, first Ethernet, we're going to say the gateway is 2.2, and then we're going to so this end device is also done. And let me configure this. We're going to say this fellow 172.168.0.1, and their gateway is going to be 0.2. Right? This they're going to here, I'm going to say your IP address is going to be 0.2, the gateway. This is your default subnet mask. So we have done the end devices configuration and gateway configuration. We will also complete this 3.1, 3.2, and 3.3. Let's see. So for the router serial interface, I'm going to say your IP address is going to be 192.168.3.1. For 3.2, So for the router serial interface, I'm going to configure it as a 3.2. And for this router serial interface, I'm going to configure it as a 3.3. All right. So that's so what we have did. We have assigned the IP addresses everywhere. That is the second step. Third step, what we're going to do is we are going to tell routers, right, to use any dynamic routing protocol. We're going to tell the routers to use any dynamic routing protocol. It might be a RIP or it might be EIGRP, where they route the packets or broadcast the packets. Right. So let me tell that router. So I'm going to tell this router saying that like this. I'm going to say router RIP. Let's use a RIP only. I'm going to say network 192.168. 1.0 is directly connected, and network 3.0 is also directly connected. Look at this. This is 3.0 directly connected. Okay. Let me tell this router also. I'm going to tell this router. I'm going to tell the router RIP. I'm going to tell network 172.168 0.0 is directly connected, and network for this router also 192.168 3.0 is directly connected. Because for this router also 3.0 is directly connected. Okay. Let me tell this router also. I'm going to tell this router RIP. There is a network 192.168.0 is directly connected. There is a network 192.168 3.0 is directly connected. So you can see even for this router also 3.0 is directly connected. So step 3, we tell routers to use any dynamic routing protocol. We have used here RIP. We have used RIP here, and we have said using a RIP, we have said this is a routing protocol. We have to. Now, step number 4, what we are going to do is now is we're going to create DLCI numbers. We're going to create DLCI numbers. Look at this carefully. For this router, right, I'm going to create DLCI numbers as one is 102 and the other one is probably I may use 103. Now look at this, why I've created this way. Because these numbers are important and it will be easy for you to identify at any case, any situation. Now you can do, there are some reserved numbers, probably in the slides, I'll put the reserved numbers. You cannot use those numbers. Apart from those numbers, you have to use other numbers within a range. Now, the first thing, when I say DLCI 102, what does it mean is 1 represents to a router 1, 0 is going to, 2 represents to a router 2. So I created 102 identifier for the packets which are traveling from router 1 to router 2. I use a DLCI number 102. So I repeat, how this 102 we have used or framed is easy to remember at any point of time. 1 represents to here from a router 1. Packets which are going to a router 2, I use a DLCI 102. Similarly, from a router 1, the packets which are going to router 3, I use a DLCI number 103. Right? This is the easy way to create and or let's say best practice to remember the DLCI numbers also. So if it is a case for router 2, look at this. I want to create DLCI here. I'm going to create 201. That means from router 2, the packets which are going to the router 1. And I'm going to create another DLCI, probably 203. The packets from router 2 going to the network, or let's say router 3, I'm going to use the DLCI number 203. And here, I'm going to create something called 301, the router 2 to router 1 if the packet goes, and 302 from router 3 to router 2 when the packet travels. These DLCIs, we are going to create it. So that's what, let's see how do we create it also. All right. So fourth step, we're going to create DLCIs and we are going to map also. We're going to map also. How do we map that? How do we create and map? Right. So for that, I'm going to the WAN now. This is the first step. Our first time we are going for the WAN emulation configuration. So I'm going to the WAN emulation and then I'm going for the config part. Now, in the WAN emulation, the config part, you have frame relay, DSL and cable connection, then you have some interfaces and so on. Now, if you see for this WAN emulation, we have interfaces serial 0, 1, 2 and 3. Moreover, 3 we have not used as of now. We have only 0, 1, 2 which have been used. Okay. So now I'm going to the serial. All right. The moment I serial, by default is an on. Let's not worry. And there is a LMI type. Let it be Cisco proprietary only. There are other LMIs. Let's not worry about this LMI type. Right. The first thing I'm going to tell here is 102, the DLCI which we have generated here or to generate 102. All right, is intended for router 2. That's what we're going to add. You can see 102 from this, or let's say, is from the serial. From this serial, 102 is intended for router 2. Right? Similarly, 103 is intended for router 3. We're going to add it to the WAN emulation. That's what you can see for this serial. We are trying to configure here, saying that 102 has to be or it has been designed for router 2, and 103 has been designed for router 3. That's what we told in a serial 0 place. And serial 1 place, we're going to tell serial 1. What is serial 1? This is serial 1. We're going to tell 201 is intended for router 1 and 203 is intended for router 3. All right. So that's I'm going to tell it here. And then I'm going to tell in the serial 2, I'm going to tell 301 is intended for router 1 and 302 is intended for router 2. Right? So this is how we are going to create a DLCIs. We have not mapped it. We have just created. Mapping is the next stage. All right. As I said, the first level, we have just created the DLCI numbers and then we'll map it. So how do we create DLCI numbers? This is the best practice. Name the DLCI identifiers, data communication link identifier numbers, like one which represents to router 1 to router 2 and so on, as we have discussed. And if you also observe, there won't be any DLCI called 101. There won't be any DLCI called 202. There won't be any DLCI called 303. That is a self. We need not to create it. Now let's map this. Right? That is the next stage which we are going to create, which we are going to do. Once we create a DLCI numbers, now we are going to map those DLCI numbers. But mapping is, we should be very careful when we map it. Right? Look at this. For mapping DLCIs, what I'm going to do is, okay, we'll do one thing. People are texting. We'll take a break for now. Now it is 9:35. We'll come back 9 35 in the sense 45, 50, 9:50, we are going to come back. Is that fine? We'll take a break now. We'll come back at 9:50. Is that fine, everyone? Or you want me to continue and close? So now, as of now, what we have done is we have just created the DLCI numbers. Right? Now we need to map these DLCI numbers. Right? But when you map, this is a very let's say a challenging situation. Your mapping should be done perfectly. If your mapping is done wrongly, then you may end up using a routing loops, or you may end up having a routing loop. The packet will rotate there only; it will not deliver. So the mapping is very important stage in the frame relay. If something when you map, something goes wrong, you will end up having a routing loops. Okay. Now let's see how do we map it. Now again, this mapping also can happen in two ways. The first type of mapping we call it as a static map. The second type of mapping, as we have done a dynamic way, we have a dynamic map also automatically it takes care, right? As you have seen a static routing and dynamic routing, right? But it is always best or good practice to understand this map, static map, so that you will understand the concept. Dynamic map, you may not understand it because it happens in the back end, right? Let's see the static map, how it does. So I'm going to click on frame relay. So look at this. There is a frame relay here. I'm going to click on frame relay. Now, the first step is there is a serial 0, 1, 2, 3. All right. This is kind of a source, and this is kind of a destination. Serial 1, 0, 1, 2, 3. All right. Sublink, we'll see what is that. So source port and destination port. Right. Now, if you see source port, the moment you select serial 0, you can see R1, R2, and R3 are enabled, for which we have assigned already DLCIs in the previous step, creating a DLCI. If you see serial 2, serial 1, R2, R1, and R3 are enabled. If you see serial 2, R1 and R2 are enabled. If you see serial 3, nothing is enabled because we have not created any DLCI. We have not done any DLCI number. Similarly, the other side, you see serial 0, there is a R2 and R3. If you see serial 1, there is a R1 and R3. All right. When it is serial 1, R1 and R3. When it is serial 2, all right, this is serial 2, then you get a R1 and R2. You have it. So now let's map this. So first I'm going to map this way. I'm going to select, all right, serial 0. That means this. Look at this carefully. I'm going to select serial 0. And the packet has to go to R2. The packet has to go to the router 2. Serial 0, router 2. I'm going to. Then the packet has to come back via serial 1 to R1. That is already in R1. See, you understand this first part. Serial 0 goes to R2, right? We are using backend. We have already created DLCAs. So let's not worry about the DLCA number now. We have to deal with the router. So serial 0, the packet goes to R2, has to come back via serial 1 and to R1. All right. So that is the first static map we added to the frame relay database. So serial 0, R2, serial 1, R1. So that means we have done this. We have done this part. All right. Now let's do this part, right, from here to here. So look at this. The packet goes from serial 0 to R3, has to come back via serial 2 to R1. Right? I'm going to add that to the frame relay map. The packet goes via serial 0 to R3. The packet has to come back via serial R1 we have done. So if you see carefully now, all right, we have done this part, the packets going this way. We have done this part, the packets going this way. Now what is the path left? Sorry, it's not getting released. So let me. So the first part we have done this way. Part we have done this way. Now what is the path left now? The path left is we have to do this way. All right, let's see. That will do it now. Means the packets going via serial 1 to R3, the packets going via serial 1 to R3 has to come back via serial 2 to R2. So that means this path we are trying to establish. We are trying to establish this path, and we're going to say add. So 3 entries added. So one, this entry we have added. Second, we have added this entry. Third, we have added this entries. So that's what we did. Part of our frame relay, we created DLCIs and we have mapped the DLCIs. All right. The next, the fifth step. All right. Now I'm going to tell all the routers about the frame relay. I need to tell them we have done the frame relay at there is a emulation here, and we have configured some frame relay here. And the routers also have to understand. As of now, routers are unaware. You can see here only what we have done with respect to the routers. We have connected, we have assigned the IP address, and we have just told about the RIP. Nothing else was told to the routers. So now, as a fifth step, we're going to tell the routers, boss, there is a frame relay enabled, and you have to connect it in this way. Right? Let's see how we're going to tell that. All right. So I'm going to the first router. Okay. I'm going to the enable config terminal mode. All right. I'm going to the interface serial 2/0 because the packet goes from this interface only to the WAN emulation. That's why I'm going to this interface and I'm going to configure. Right? I don't want to configure on top of the router. I'm configuring to the particular port or interface, serial interface. And I'm going to say encapsulation frame relay, saying that we have used a frame relay. All right, that I said. And there is an optional one. You can even set the bandwidth also for this. You can just say bandwidth 64,000, whatever it is. For this channel utilization, you can set the bandwidth also. That is optional. Then we're going to say frame relay. Now we're going to map the IP. We're going to map the IP. Look at this. 192.168.3.2. So I'm going to map this serial interface with the 3.2. The packets going to 3.2 has to use the DLCI called 102. Look at this carefully. I repeat, there is a static happening here. We're going to say frame relay. All right. We're going to say frame relay. Okay. All right. So we're going to configure a frame relay map. Frame relay map 192.168. So I'm tell this router at this interface, the packets which are going for 3.2 has to be having or mapping to be 102. And I'm going to broadcast it. Right? I will not tell about 1.3. It has to learn automatically. When it will learn automatically, we'll also see that. We just said one path now. I mapped this router to 3.2. Let me map this router to 3. Let's say 3.3 and map this this router to 1.3.1. So I do it in a circular way. When I do this, the other DLCA's mapping has to be happen automatically. Let's see whether it will happen or not. The first thing, coming back to this point, so I'm just telling the router in that particular interface, I'm saying the 102 is mapped to 3.2, intended for 3.2. That's what we have mapped here. First up, we said there is a frame relay which we are going to use. And then we are going to frame relay map 3.2 with 102 IP address, sorry, DLCA, and we are going to broadcast it. Okay. Then I'm going to this router. Look at this. Enable config terminal interface serial 2/0. So I'm at this place. So first up, I'm going to tell is encapsulation frame relay, right? Bandwidth maybe 64, and I'm going to say frame relay MAC IP 192.168 3.3 with DLCI 201. Sorry, 203, not 201. So the packets which are going from here at this, I'm mapping to 3.3, intended as 203 DLCI number, and broadcast. I'm going to say exit. So this I've told you. Now I'm going to tell this router something similar. Enable config terminal interface serial 2/0. Then I'm going to say frame relay, sorry, encapsulation frame relay, bandwidth might be some 64. Frame relay map IP. Now I'm going to map 192.168, right? 3.1, and the DLCA is 301. And I'm going to broadcast it. So it has already learned by this time. Look at this. It says address already in map. It has learned already. Let's not worry about it. Right? Okay. So that is a fifth step. Sixth step, I'm going to verify. Verify what I've configured verify with the routers. Routers about DLCAs. Whether it has learned or not. Learned or not. Let's see. So I'm going to ask this router. I'm going to ask this router show mapping table. Now look at this. This router we have configured only 102. All right. So it has already done in the backend 103 also. Look at this. For 3.3, it has already mapped 103. Let me ask this router. Exit. We're going to ask show frame relay map. Look at here. Here also we mapped only 203. About 201, it has learned. Because when it is exchanged, the second path it has learned automatically. How it has learned automatically? Remember the fourth step where we created DLCAs and we have mapped the serial interfaces. From that, it has learned. Okay. Let's ask this guy. Show frame relay map. See 3.1 and 3.2. It has learned. So we are almost set to go. So let's last one is we're going to ping. We're going to use the ping command and we are trying to ping the end devices. Let's see we'll be able to ping or not. Hopefully it should work. As we have done everything correct. We make a packet from here to here. Okay. Yeah. So forward. Yes. ARP. That's not very. Second packet will try. First packet PTL expired. Look at that. So now what happened? Up to here we have used IP addresses, but here we have used DLCIs for the communication. So this fine. The other way will let's test from here to here. Yes. Again, this is the first connect, first packet here. PTL expired ARP failed. Second packet. This path is also fine. No worries. It's just the last part from here to here. All right. So we are done. So now if you see, I repeat, up to here we have used the IP addresses. Up to here we have used IP addresses. But at this stage, all right, the DLCI's role comes and they will help us in transferring the packets. All right. So going back to our presentation, if you see in the slides, I've given explanation there only. This is a frame relay packet format, how it happens. Then in between the cloud emulation, it might be in a start topology or it might be a mesh topology or anything can be happening in between cloud emulation. And this is what the DLC is we are trying to understand, which I explained in the simulation, and how the DLCs will get communicated, all right, through frame relay. That's what we have done in the simulation. Even how to configure that also, 102, 201, 203, or whatever it is. We have done it in a topology. And the exchange or mapping of DLC, or let's say the commands. So we said encapsulation, frame relay, bandwidth, and frame relay mapping. This also we have covered in the simulation, frame relay map. And explain the reachability issue associated with the frame relay. So this NDA topology, it's not worry. Just try to understand. If you don't map it properly, you may end up with having a routing loop. So that is one of the issue. So that's where we use the split horizon rule. It's not worry. All right. So that the map should happen properly and routing loops has to be avoided. Now again, if there is any routing loop, so look at this carefully. Let me give you an overview here. Just one insight. So we have studied something called split horizon rule earlier. What is the property of split horizon rule or purpose of split horizon rule is it will try or it will make sure there is no routing loops. Right? How it makes? It says when the packet is sent from one source to the destination, or when the router broadcasts information through this path to router 2, all right. Now router should not broadcast the same information back to the router 1. That is a rule of split horizon. So if I give you something, you should not give me the same thing back to me. You should give me an updated if you have. All right. If you don't have updated, let's leave it. But don't give me the same packet back to me. The moment if you give me the same packet back to me, I may end up having a wrong configuration, wrong analysis, right, which will create a routing loop. Right? That's what the split horizon rule says. When some update is sent from R1 to R2, R2 should broadcast that update to other routers, not for R1 again, the same update. If there is a change in the update packet, it can broadcast. But if the same packet or the same packet cannot R1, that's the rule of split horizon. Look at this. Update received on physical interface or not transmitted out of the same interface. That's what out of that same interface. So that's an insight which will help us to all right clear the routing loops or whatever. So this frame relay busting okay, is a standard format and interface how to configure or verify. There are two more commands where you can verify, let's say, the frame relay. You can use a show interface summary. There you can identify the frame relay and these points. So verifying show interface serial, whatever it is. Then you can verify the DLC. You can see you can verify the DLCI number and frame relay, all those things. Right? So troubleshooting again, you can use a debug frame relay LMI. Let's not worry about this command. Okay, that's good to go. So that's all about the frame relay. All right. So any doubts with respect to the topology? So I'll try to address if you have any doubts as of now. So we have tried to cover point-to-point protocol, a theoretical, and frame relay probably in a simulation based. How what is frame relay and how the frame relay. Part of frame relay you have PLC numbers and other things. Any doubts as of now? So we discuss about the scheme and solution for the open-ended test. So before I discuss about the scheme and solution for the open-ended test, I strictly say keep your open-ended test answer scripts simply because you may have to submit those hard copies back to me once the college is open. All right, that is point number one. So at any cost, if you say that I have lost that, which will not be accepted. Right? So your marks will be released only after verifying your hard copy. Though I have evaluated and kept the marks in the hidden mode or in the draft mode, it will not be published to you until I verify the physical or let's say hard copy of your scripts. As of now, this is the instructions as of now, which even we have received. So similarly, okay, if people who have not attempted, I know there are hardly 4 or 5 people who have not attempted the open end. For those people, we have to wait for the instructions how the open-ended test will be taken or what is the steps to be considered or how it has to be held. There is no absolutely there is no let's say it as a information for me as of now. All right, but we'll see how we can address that. All right, then the people there are 1 or 2 people who have one or mailed me the open-ended test just 2 days back. All right. I guess from ISC 1 and CSE 1. Well, that script will stand as a withheld until the committee process it. We may not consider that for. Maybe you would have had a discussion with the HOD. All right. Once the HOD gives the instruction, then only those scripts, 2 scripts will be evaluated. And there is one person who has attempted the test and who have not submitted the script. So I will communicate to that person individually, that is from ISC. Let's address that separate. Okay. Now, let's go to the. So the first one is protocols must account for the following requirements. This is a straight question from your presentation. It is all above. The answer is all the above. It should have an identifier to send and receive. There should be a common language and grammar, that is protocol, or we say speed and time of delivery, confirmation and acknowledgement required. The answer is all of. Second, common must be in agreement with the following requirement. Straightforward question from your presentation. All right. And again, the answer is all of the above. Fine. Dash manages the rate of data transfer, how much information can be sent, and the speed at which it can be delivered. Now, the answer is flow control. This will tell the rate of how much speed the data has to be delivered, what acknowledgements. Again, it is part of your data link layer protocol. Sorry, data link layer. That's why we have discussed something called medium access, contention based, or control based access protocol. Next, Dash delivers the messages from NIC to another NIC on the same Ethernet local area network. All right, it's simple. It is transmission control protocol. Fine. Next, Dash layer needs to provide a reliable mechanism for exchange of data between two processes in different computers. Who has to take care of the reliable mechanism, or let's say it as a exchange of information? The network layer. Dash allows you to use use more than one subnet mask within the same network address space. A subnetting is a subnet, which will allow a variable length mask, which is not part of DHCP operation. Discovers, DHCP client broadcast DHCP discover. We said not part of DHCP operation on local subnet. DHCP server sends offer. Yes, this is part of DHCP. DHCP broadcasts the public IP and private IP address to all the routers. DHCP client select release whatever it is. DHCP select DHCP server and sends DHCP. Now, this public and private IP is not broadcast. Fine. Then observe the topology. What command is used to display the following output? Show IP route. Simple. For any topology, you need not to observe this topology also. Any topology, if you get a routing table, show IP route. So observe this topology. End devices on the same VLAN. So what is needed to allow the communication between the VLANs? Obviously, inter-VLAN routing. A route with a sub-interface configured on a physical interface that is connected to the switch. Inter-VLAN. Which of the following is not the type of ACL? These two, permit, host, they are not type of ACLs. Standard and extended are type of. So answer is A. 1 and 2 are not type of not type of ACLs. So that is with respect to CQ. Now coming to the second question, which layer provides the logical addressing that routes will use for the path and for the path determination? Discuss layer 2 and layer 3. Obviously here network layer. All right. This will provide IP addressing. You have to talk about that. Here you have to talk about again data link layer and network layer. That is addressing, MAC addressing and IP addressing. That you have to discuss about here. So explain the characteristics that underlying network architectures architectures need to address to meet. Here it is expected as the 4 minimum properties, that is scalability, reliability, quality of service, and scalability, reliability, quality of service, fault tolerance. I'm supposed to explain it here. Right. Now, fourth question: list the different protocol suites. The role of presentation. So you have to list here. There is a layer model, TCP/IP model, Apple talk, and NetWare model. You have to list all those models here. Or let's say it as a presentation, these 4 layers in a OSI model. So it's a simple. Now, again, dynamic IP addressing. To discuss about static addressing, or let's say it as a dynamic IP. Again, here public and private networks. Even you can say public and private IP addressing. So both the same. You have to give a comparison. 2.5 mark comparison. Here describe IPv4 addressing. The expected here is we have to say what is IPv4. You have to say what is network address, broadcast address, usable host IP address. You have to say network portion, host portion. You have to say the range of IP addresses. All right. You have to say classes of IP addresses. For each class, what is a network, what is host portion, what is the default subnet mask. All those things you have to explain here. And here the need of VLSM. So probably the continuation to this, you can say this is a limitation, and you have to say what is VLSM, taking an IP address, a class, any IP address, and how do you subnet it, right? That you have to explain. So this is a simple one which you have done for your assignment also. Equivalent subnet, you have to fill this. 8 equivalent subnet in the sense how many bits you have to borrow? Only 3 bits. And this also we have done in the. This is a requirement. This is IP address given. Based on a requirement, you have to subnet the IP address. Right? I'm going to consider the first. If you have done the first this correctly, I'll be giving 4 marks. The remaining 2, 3 marks each. Then, so discuss the access control list, standard and acceptable topology. Take any topology. Freedom is given to you. You can take any topology. You can say what is standard access control list. You can also explain what is extended. Here you need not to explain about the commands. You just need to explain about the concept. That is good enough. If you have given the commands, well, then more good enough. Need not to worry. Then, for a given a topology, assume static routing is. See, I hear from some students, sir, for the question number 7 and 10, we have to configure it, then only we can able to write the addressing. See, for writing the routing table, you need not to configure. From this itself, you can build the routing table. If it is a static routing, you can easily build the routing table from this itself. You don't configure it. You should be in that level. By seeing the topology, you should be able to say routing table. Only if I configure, then only I will copy paste the routing table. No, that is not a. So if you have configured quickly, okay, but it is not a good practice. But from the topology, you should be able to say the routing table when each and every detail is given in the topology itself. IP addresses, everything is given in the topology itself. Right? You should be able to say easily. And even for dynamic routing, see, for dynamic routing also, you need not to configure it here. It's so simple. You have a router 0, router 1, router 2, whatever it is. So what it will have? Directly connected network. This one, indirectly connected network, these ones. It is easy to build the routing table. You need not to configure this. That's the reason the topology is given to you. If I see this topology clearly, I can say routing table of R0. What will I have? The routing table in R0. Say it as a directly connected C using 1.0 network via fast Ethernet, let's say 0.0. It is connected. Similarly, I can even say 5.0 network is directly connected C, and 4.0 directly connected. I can put it in a routing table, and I'll say 2.0 is connected via, let's say, 192.168 5.2 with a hop count of 1. So this you can easily write. You need not to configure it. You should be in a stage that by seeing the topology, you are able to write this. So that is what expected. I never mean to you people to configure the draw the or write the routing table. So what is my expectation is you should save the time here. You should save the time here instead of configuring. You should build the routing table from this itself. If you are configuring and if you are writing it, copying the routing table, it's not a learning aspect. It is like though you know the configuration, you're not understanding the routing table. So that is what I expected actually. But I understand many students have gone to the simulation, try to configure this, try to ping this, try to troubleshoot it, and spend a lot of time in evaluating. No, I didn't ask you to ping anything. Did I ask for any pinging status? No. I just asked draw or list the routing table entries for all the routers. You just need to say R2, all the entries you need to write it. That you can get it from the topology itself, both the cases. In fact, you would have saved a lot of time in these two, 10 and 9 and 10. No worries. It is a good practice for the next time when you do the exam, configure, but try to see the topology and try to build it. All right. So that's all about the question paper. Right? See how I'm gonna evaluate it or how I'm gonna consider it. So if you have any doubts, you can ask me now with respect to the open-ended test. If you have any doubts with respect to the open-ended test, you can ask me. Okay. Sorry, let me go to this only, then I'll come back. Sir, will you be mailing the scheme? Yes, I'll prepare. Keshav, I'll prepare the scheme and I'll mail you also. Need not to worry. What is expected as we have discussed? What is the minimum points expected? Right? Minimum points. I'll mail that also. Need not to worry. Any other queries with respect to open-ended test? Okay. So if there is no queries, we'll go to the last. Okay. So also, can you have a session to write? Okay, that Keshav, this we can take it on Friday. Doubts clearing session. I'll help you. I'll tell you by looking at topology how to write a routing table or what way you can draw the routing table. I'll take this session in the revision or let's say it as a session. We'll take a session on that. Okay. Any other? Any other? So if there is no other doubts, there is one last action point. I wanted to. This is with respect to assignment 5, which will be enabled. Assignment 5, I made it very simple. All right. If you have attended ACL session, you'll be able to configure within a half an hour. Right? I made it very simple. Let's look at to that. What is assignment number 5? So the topology. This is a topology given. So there is a 4 routers: A, B, staff, and IC router, and subsequently these are the networks connected to that, and there are servers also under each network. Right? What is the first task given to you? The first task is assign the IP addresses for all the end devices using a DHCP server. So you need to host a DHCP here and assign the IP addresses using a DHCP, and you can use from 1.0 to 1.8. So it includes 1.0 here, 2.0 here, 3.0 here, 4.0 here, 5.6.7.8. Right? You can use that. And host yourname.com. That means with your name, host a web server in the server 1. Where is server 1? Here you have to host yourname.com. Example www.keshav.com or vivek.com. You are in the server 2. You have to host a web server using your USL. Subsequently, in this, host your facultyname.com, host your departmentname.com in server 4. All right. EIGRP dynamic routing across the networks. So you have to use EIGRP routing to send the packets, to send and receive the packets. Okay. Task 2, and again, place, sorry, spelling mistake. Okay. Correct. Place the screenshots accordingly. What is the task 2 is? Reaching a yourname.com using a standard ACL. So yourname.com will be hosted in this server, and you have to restrict laptop 3 reaching this server. All other you can permit. Right? Is what again, restrict laptop 0 reaching your USN using a standard ACL. So your USN is hosted here. So laptop 0 is here. You have to restrict laptop 0 reaching that particular server. All others can be permitted. So that you have to configure using a ACL, standard ACL. And task 3, allow laptop 7 reaching your, but restrict ICMP packet using extended ACL. So allow laptop 7 reaching your department. Where is laptop 7? Laptop 7 is here. Your department is here. So allow laptop 7 reaching your department, but CMP packet from laptop 7 has to be blocked to reaching there. That you can do using an extended ACL. Similarly, vice versa, laptop 4 reaching your facultyname.com, but restrict ICMP. So that you can extended ACL. And task 4, allow all other pings across the different networks, and you have to place the screenshots accordingly. So apart of these 4 restrictions, remaining all, everything has to work fine. Right? Only these 4 are the ACLs which we have asked you to configure. So that you have to configure in this topology and send it across. All right. So that's your assignment, and will be enabled at 12 p.m. today, and you can submit by Saturday end of the day. Right? It is a later another 1 week is also there for people who submit, but it will be considered as a late submission. So that's as of now. Sir, may we know the weightage of these assignments if it has been decided? Not yet decided. Not yet decided. As of now, we have not got any information about the weightage of the assignments and the weightage of the open-ended test. I also understand there is another type of test is going to come, that is MCQ test. Right? So hopefully, I feel all the equal, or let's say it as a desired weightage. All may have a, based on efforts, what you're gonna put. Right? The weightage will be accordingly. Just let us wait for the instruction. That's it. Any other doubts? So if no other doubts, so can we end the session? And people who have not dropped hello message in the chat box, please drop hello message so that your attendance gets recorded for me. All right. So if any other information or if any other doubts, you can ask me. If not, we'll close the session. I'll wait another 1 minute for taking the doubts if anything is there. If not, after 1 minute, I'll close the session.